All right, so today's notes are on systems with three variables. Our content objective is to solve systems in three variables using substitution and elimination. Our language objective is to use correct terminology when explaining how to solve systems in three variables. So I started by writing down the three overarching parts to solving these problems. So backing up for a second, a system in three variables is a system of equations with three variables. So the first thing I want to note is that if you have three variables, you need three equations to solve. Just like when we had two variables, we needed two equations to solve. Now we have three variables, we need three equations to solve. Otherwise, we can't actually get values for the variables. All we can do is isolate one or two variables. So in order to get actual values for a three variable system, you need three equations. So when we're trying to solve them, there's sort of three overarching parts. The first one, we start with these three variable systems, which I'll show you for our example in a minute, but we're going to start with this three variable system. And then our first goal is to get this down to just two equations with two variables. So we'll have to use all three equations, but then we can get two equations with two variables, which is our normal system, or what we've been solving the past three lessons with substitution, elimination, and graphing. So once we get that, so once we finish part one, we get two equations with two variables, then we can solve the normal system of equations. So that would just be our two variable equation system. That we just do like we've been practicing the past couple of classes. So we can use substitution or elimination. Once we get our x and y, or our y and z, or our x and z values in that two variable system, then we just work our way back by plugging them into the other equation. So we plug this back in and solve for the last missing variable. So let me show you an example. I'm going to take you, just as a forewarning, I'm going to go sort of a roundabout way so you can see the long way of doing this, because not all the problems, there's a shorter way to do it, but not all the problems will have such a shortcut. So what I'm going to do what the problem asks is, what is the solution of this system? And it has 2x minus y plus z equals 4, x plus 3y minus z equals 11, and 4x plus y minus z equals 14. So just to tell you, the shortcut would be to use elimination with these two equations, because it's going to cancel the z and the y, and then you just have 6x equals 18, so x is 3. I'm going to take you a little bit roundabout way so you can see what you should do if you have a longer or more challenging system where it takes a few more steps. So I'm going to flip the page because this does take a few or a little bit more space. So what we have here, I'm going to rewrite the systems. So we have 2x minus y plus z equals 4, x plus 3y minus z equals 11, and 4x plus y minus z equals 14. So I'm going to number these 1, 2, and 3 because we're going to be mixing them up a bit. So I'm going to start by taking equations 1 and 2 and using elimination. So I already know that my z's are going to cancel because they have the same coefficient, 1, but then they have opposite signs. So I know they're going to cancel. So I'm going to use elimination, cancel those out. So I have 3x plus 2y equals 15. So there's my first two variable equation. So I'm going to put a little note, two variable, because now I have a two variable equation to work with. Now I'm going to do the same thing with my other two. So again, if I was trying to be smart, I would have just done the first 1 and 3 from the outset. But because I'm trying to show you the longer process, I'm going to use 2 and 3. So in order to use 2 and 3, I'm going to have to multiply one of them by -1. So I'm going to multiply this equation by -1. So I'm going to take equation number 3 and multiply it by -1. So I end up with -4x minus y plus z equals -14. So I just multiplied equation 3 by -1, and I ended up with that. So this was equation 3 originally, but multiplied by -1. And then I'm going to use equation 2 again. So I'll use equation 2, which is again x plus 3y minus z equals 11. So again, I'm just using elimination. So this becomes -3x plus 2y, z's cancel, and then I get -3. So now I have another two variable equation. So I've done part one. I used my equations to make two equations with two variables. So now I'm going to use these two equations, which I'm now going to number 5 and 6, so we can keep track of them. But I'm going to use, sorry, that should be 4 and 5. Jumping ahead of myself. I'll label this 4 and 5. Sorry, 4 and 5. I skipped 4 after 3, I don't know. So then I'm going to take 3x plus 2y equals 15, and I already noticed that my x's have the same coefficient and opposite sign, so I can again use elimination. So this was equation 4. I'm going to use equation 5, negative 3x plus 2y equals negative 3. And then those cancel. I end up with 4y equals 12. So y is equal to 3. So look at that. I've solved for one of my variables. Now I'm just looking at my two variable system. I can plug it back into either one to solve for x. So I'm going to plug this back in to solve for x. I'll use equation 4. So I have 3x plus 2 times 3 equals 15. So again, I just plug this in to that equation. So I have 3x plus 6 equals 15. 3x equals 9. So x is equal to 3. So now I have two of my variables. Now I've finished. So if you're thinking, or if you look back to our part one, or sorry, not part one, our first thing here, we did part one, we made two equations, two variables. We did part two, we solved our system. Now we're on to part three. We're going to plug in the values we got back into one of the original equations. So I can plug this back into either of the original equations, or any of the three original equations. So I'm going to plug this one back into equation 2, I guess. Doesn't really matter, but I'm going to plug these both into equation 2. So I'm going to say 3 for x plus 3 times 3 for y. So I'm plugging in case you forgot, this was x plus 3y minus z equals 11. So minus z equals 11. So I end up with 3 plus 9 minus z equals 11. 12 minus z equals 11. Negative z equals negative 1. So z is equal to 1. So now I've solved for all three variables in my system. I know that was a lot of steps, but I hope you see the overarching theme is you're trying to cancel variables to get a two variable system. Once you get a two variable, you solve for each one like a normal system.